In this video, we will be learning about force exerted by jet on a vertical flat moving plate in the direction of jet. So in previous video, we have learned about how to find the force exerted by jet on a vertical flat stationary plate. But here we are considering the flat as a moving plate. So the flat plate will also have a velocity. So I am considering initially a jet of water with a velocity v striking on this flat plate, and we know that the flat plate is also moving. That means it will be also having a velocity. Let that velocity be u. So the flat plate initial velocity will be the combined velocity, right? Combined velocity in the sense it will be the relative velocity, that is the velocity of jet minus the velocity of the plate, that is v minus u will be the initial velocity, because as both velocities are in the same direction, right? The velocity of jet of water as well as the velocity of moving plate, both are in the same direction. So relative velocity means v minus u, that is the relative velocity that is initially acting on this vertical plate. And as we all know that immediately if a jet of water strikes on the plate, it will be deviated. So here v minus u, it will also be deviated as v minus u and v minus u. So the flat plate that we are considering here is a smooth flat plate, so there won't be any loss of energy. So water that is striking, after striking, it will be deflected at a 90 degree and it will be completely deflected. So we have to find the force exerted by the jet, and it is in the direction of jet. The jet is in which direction? It is in x direction. So we have to find the force exerted in x direction. That means Fx we have to find. So Fx is equal to, we all know that the force exerted will be the rate of change of momentum. Rate of change of momentum. So momentum means mass into velocity. Change of momentum means initial momentum minus final momentum. And rate of change of momentum means whole divided by time. So from here we can take m as common, right? So m into initial velocity minus final velocity by time. And mass by time, mass I can write as density into volume by time and into initial velocity minus final velocity. So initial velocity, as we all know that initial velocity is v minus u. So I can write initial velocity as v minus u, and final velocity after striking in x direction, is there any final velocity? No. Vf is equal to 0. So the final velocity is 0, and rho into volume by time. Volume by time I can write as density into area into initial velocity, right? That is mass by time. Mass I can write as density into volume by time, and volume by time, volume it is area into length. So density into area into length by time. Length by time is velocity. So rho a v. So here initial velocity, as we know that v minus u. So I am substituting initial velocity, and the equation will be rho into area into initial velocity v minus u into v minus u minus 0. So Fx is equal to rho a v minus u the whole square. This is the force exerted by jet on a vertical flat moving plate in the direction of jet. So the second thing we have to find is work done per second. Work done per second, which is actually the work done by jet on the plate. So we all know that the work done equation is force into distance. Force we are considering in x direction, so Fx by distance, into distance, and work done per second means divided by time. So this will be actually velocity, right? This will be u into Fx. So Fx we have found that Fx is equal to rho a v minus u the whole square into u. So this will be the work done per second. And the third thing that we have to find is the efficiency. Efficiency, we all know that efficiency equation is output by input. So what we are actually getting as output? Output we are getting as work done per second, right? Output is our work done per second. And input, what we are actually giving is the input. Kinetic energy of the jet is the input, right? We are giving water is actually striking, so kinetic energy of jet is our input. So work done per second, we have found that rho a v minus u the whole square into u, and kinetic energy of the jet is half m v square, and m we can write as m is equal to density into area into initial velocity. Initial velocity we have to write v, because from the nozzle we are giving the water, right? That is kinetic energy of the jet, means the velocity from the nozzle we have to consider. It is striking with the velocity v, so we have to consider v, not v minus u. So mass is equal to rho a v. So again the equation will be rho a v minus u the whole square into u by half m I can write as rho a v into v square. So this is the efficiency. So if you like the video, subscribe the channel and share with your friends. Thank you.